Hello everyone. I will talk today in this session from the Chaos Code to Hexagon Architecture. My name is Oussama BADR. I'm CTO and software engineer at Agile IT in Paris. I would like to thank MenderCon conference for having me for this session. And please, if you have any questions, put it on the discussion. And if we have time, we can answer it after the session. Or if not, we can chat after the session to the end, of the conference. So, what we will discuss. For this session, we will talk about legacy in general and other stuff to consider as well, and Hexagonal to the rescue, and Hexagonal in action. I will show you a demo, and at the end we'll have some conclusion and some thoughts about how to handle this transition. So legacy all around. We know that we have the legacy in all our, we encounter a legacy in all our projects. So we have the layers architecture, we have the spaghetti architecture, we have this CV architecture, and like people try to just put some frameworks and technology just to put them on their CV for next job. And we have many architecture and many patterns, and even we don't even we don't design our software correctly, it will design itself in some chaos code and some unpredictable code, which may slow down the overall value we want to deliver to our customers. So legacy code, the definitions. I took this definition from the Working Effectively with Legacy Code books from Michael Feder. Legacy code is simply code without test. And this is totally right, because if we want, because legacy, when we wrote a code in today, so tomorrow it will be our legacy. So if we don't put tests, if we don't work with TDD specifically, test-driven development, we will have this. We will be frightened by changing this to change this code, because we may introduce bugs in production, so we're afraid to change it, and at the end it will add up with other codes, and we end up with a spaghetti and with legacy code with no design. So testing definitely it's very important to handle this legacy code and this legacy in general, because if not, we will definitely be in trouble, and we may end up by losing our job, or bankruptcy in the company, or losing our customers, because we can't fix bugs. So testing is very important, even though in my experience, I saw many projects, even today, without test. And it's not easy to convince people to put test, but if you are the example by introducing testing in the project, and when you show that you have less bugs in your features that you deliver, people will follow, and even manager will be convinced that this practice is very effective and very efficient for the team and for the customer as our end users and our priority. But I have added some point to this definition by saying that legacy code is also code with no boundaries. Means that if we don't have boundaries between layers, if we don't have this strict limitation and strict transition between business logic and technical logic in general, we may lock ourselves, and we may be locked in some technology, some frameworks. It's not about perfection, it's more about minimizing the impact of technology, because we cannot escape this dilemma by being coupled with technologies, but we we should aim to reduce it as much as possible. So legacy code is everywhere, as I said. We handle it in front end, back end, in even though in desktop application, in batch applications, even in IoT, we have this kind of legacy. So yeah, we need to pay attention, and we need to be aware of this threat that we may have in our everyday life and everyday work. So without speaking about legacy code, because this session is not about speaking about legacy specifically, but about the transition from the legacy to the hexagonal architecture as one of the clean architecture. So we know that legacy code is also known by this nested if-else, nested for loop, and while loop. So it means when we see the code, it looks very ugly, very difficult to understand. And if we join the definition of the first definition of Michael Feather about testing, if we have tests for this method, it would be easy to refactor. It would be easy to change it to more cleaner code. But if we don't have, we'll be afraid to touch it because it's unpredictable and it may have some dependencies to other stuff and to other services that we may not be aware of. So another example of legacy code is having this naming, like obscure naming of parameters, obscure naming of methods. And yeah, we have also this nested for loop. We have this around. We encounter this kind of code in production. It's not unusual to not encounter this kind of line of code. Yes, and so if we would want to talk about layers, we have this MVC and MVP patterns architecture, and we have MVVM, MVVP. So we know that we were working and we worked in this kind of project like in Spring, because when I'm talking about JVM platform, we work on Spring framework or Hibernate or Groovy and Grails. So we tend to use this kind of architecture, this kind of layers, but we end up quickly to a mess because we can end up by having like Hibernate in data in the domain layer and having this entity manager or other data access service, which is specific to our framework. And we may have also the Spring transactions, annotations, or programmatic transaction classes that is offered by Spring framework. We may have this mixing, and also in the presentation, we may also in the presentation having these entities used to externalize or to send the JSON to the end user by web application or mobile application. So it is we can have quickly this mess that we can encounter, and with the deadlines we can we don't have these strict boundaries, and even in the dependencies between layers, it's not very clear. Because we can't see the business logic where it resides and where to put it correctly without impacting the further work and the further work on the project. And yes, this is very usual to have this kind of work and this kind of problem with and complexity. And if we can see the flow of the layer-based architecture, as I said, MVC or others, we can see that we have this controller which talk with database, with model, and in the model, which is the business logic, it talks directly to the database via the entity framework, and there is no clear boundaries. There is no clear cut, and it's not decoupled from the technology that we are using for object mapping to the database. Also with the controller, we may have also in the controller the same problem. So as I said, it's not easy to handle this kind of strict decoupling between business logic, because we are focusing mainly in this talk. I try to focus mainly on the business logic because it is the value of the company. Because if we mess with the business logic, everything will be KR, and we don't and we can't predict how much it may take to fix a bug, to upgrade our frameworks. If we have some vulnerability, if we encounter vulnerability like recently in Log4j, even it's not like just for login, but if we assume that it's about like Spring or other framework, and we need to update to a newer version, we may end up with a vulnerability exposed, and we may have client who is angry, and he may lose, and we may lose the contract, we may lose the customer, we may lose also our reputation, because we are slow to react to the market in general. And nowadays we have many company that dies because they can follow the pace of the markets. And even we can lose the developers. Developers look for newer technology and look also for more productivity. And with this, if we stuck in our code, it is frustrating, and we may have this team which we can lose many talent, even with the high salary, because developer in general look for high productivity and using new technology in general, and even not using on the project, but even just to experiment about. And with hexagonal architecture, we will see that it is easy to change the outside world of the business logic, which might help us to test any framework, any newer version, without having this painful and this long task and the long branch which reside on our GitHub and our base code. As I said, the main focus for the layered architecture is on the domain model. If you can see here in the domain model, we may end up with having Hibernate, HPA, we have Spring, we have business logic as well, and we may also have Jackson. Jackson is a framework for JSON to serialize and deserialize JSON to a client, whether it's an API, whether it's a web client, another service or mobile application. But the problem, as to mention here, is that we may have this model which is a spaghetti code. We may have thin layer on control on the view, but model, because we have each time we added more features, we change the code, we will end up by having this mixing between technology and frameworks and our business logics. As I said, the whole company is locked. And why business logic? If it's not easy to change, we will be locked. If it's not easy to fix a vulnerability, to fix a bug, to add new features, to change how we pay or how we sell product, how we make transactions between others with other third service. So we will end up by looking ourselves inside, and we cannot find the keys. And if we find it will be too late, and it might be very impactful and negative impact on our reputation and even on, as I said, on the team, because the team also may suffer from working more on bugs than working on new features, than working on experiment. And if we don't refactor, if we don't think about refactoring in an architecture layer, in our design layer, we cannot at some state we will be fixed, and we will be not able to move on, and it will be very, very costly, and we will end up just either we forgot the project, or we will suffer the pain, because the code base may die after torturing, distressing all the team. Even the CAO may end up being like losing his company without knowing how to do and how to move on and how to respond to the market. As I said, people may also quit their job because we have this technical debt, and technical debt is caused by this unclear design, and also this practice of legacy code, which I didn't want to mention in this session, because there are many techniques that you can check out on the many books, like Working Effectively with Legacy Code, or other articles on the web. So yeah, technical debt may be very, very bad and may hurt the team and overall all the company. But we were working with legacy code. We will also have this legacy, we can say, mentality, or this politics inside the company, because it's not like just coming and introducing TDD or introducing a new architecture. We need to see how to introduce it. Is there who is the person who may influence the decisions? I need to also check with the older colleagues who are in the company for 20 years, 30 years. Check with them what can give them the security that your change will not impact the role on the company, because this is it. We are not living in a perfect world, so we need to deal with this. And also it might help to check the value of your solution, whether the TDD or other architecture is not like just I want to add this this framework or this architecture. I want to change the code base to the new architecture. It's more about is there any value that the company will gain from this architecture? It is honesty to ourselves before going outside and going to convince your colleague or your team, because if you are not convinced, you cannot convince others. And yeah, you can just like you can create small project on your side, or starting refactoring the code base of the production of your production code with, like, you can fork the project, you can just download the project on another folder, and you can try to refactor and check whether the test coverage is become higher, whether you have like it's more readable, and to experiment the painful and the pain of refactoring, because people may end up and may give up your solution even it is convincing. So you need to check whether it is if it will add value to the team, whether it is easy to implement, because we are in the agile mindset, and we need to be in this agile mindset by thinking incrementally, not coming and working directly on the whole code base. You prioritize, and you prioritize by looking at the code base, which is which change very frequently, because this code the code that you will benefit from if you refactor in a cleaner way and in the new architecture. Your project, on the whole project, even it is not clear, because we have this controller, service, and entity package, but you can extract just one module, the module that you change frequently. The idea is not working on the whole project, or bring in the massive change, but the idea is incrementally and make all the team at ease. Even you are bringing a new idea, because you will be convincing by also having this empathy toward your team, and also showing the result of how many bugs you like. If we have this 10 bugs per day, and you reduce to 5 or 6 or 6 bugs per day, you can be more convincing. Because if not, what's the value of your solution anyway? Because it's also about money, because more days of coding, more also more money spent by the company. So we need to have this balance between, we need to be more, we need to make our life easy, but also make life easy for the overall company as well. As I said, by having this like some chart, this is very abstract chart, but if you have some chart that you can extract from Jira, like how many bugs are you fixing, or how many bugs, like the rate of bugs per day, per week, per month that is reduced, or how many, or what is the time of developing the features. All of this KPI may help you to convince the team. It is work to do, and it is a homework to do. We can spend some extra hours to work on this, but it will pay off for sure. So the hexagonal to the rescue. So now we have talked about how what is the legacy code, what's the impact of legacy code, and the problem of the layered architecture. We will talk about hexagonal architecture. There are many other architecture, like clean architecture by Uncle Bob, and this hexagonal architecture was introduced in 2005. But first, who invented the hexagonal architecture? The person the being who invited the hexagonal architecture is a bee first. So, but seriously, who is the guy? Is this one, Alistair Cockburn, who is an American computer scientist, wrote an article about this architecture in 2005, and it is also known by poor adapter architecture, because we have this port and adapter from inside and outside. At the middle, we have the business logic, and all the independent. We have this code that is independent from the outside world, which is all the frameworks of the database, data mapping, object data mapping, to serialize the JSON, I don't know, Apache Kafka for messaging, any other technical tool that you are using, or framework that you are using to read data or to write data back are in the external side or border of this hexagonal figure. So in the middle, we have the business logic. The advantage of this architecture is because we are using this principle of dependency inversion, because the outside world depends on the inside world. So like Hibernate will depend on our business area, business logic, not the opposite. Because the problem with the architecture layer, we end up, as we saw earlier, we end up by having our service, which contain our business logic, is depending on Spring Framework or Jackson or Hibernate. So, and this will create a problem when you want to change this framework, when you want to upgrade specifically, because we don't change our framework very frequently, but we upgrade. And between two major versions, we have many new stuff, deprecated stuff, removed stuff. So we will not. It won't be easy. It may take time to upgrade, and this is about money. But if we have this business logic, like independent, decoupled, as shown in this architecture, the outside will be easily refactored and upgraded, or even changing the framework or the technology, like working with the web, and you want to add the mobile, or you want to add, I don't know, some IoT on the fridge. I don't know. You can you can just add this adapter and this port, the port and the adapter for the fridge, and yeah, you can display your the data, or you can display the information on the screen of the fridge if you would like, if you have this use case on your application. Because if not, you need to dig deeper and to check for the business logic between the line of your framework, technical framework, Spring or Hibernate or others. You need to check and to extract. It's not easy, because you may end up by forgetting some important business rule, and you may introduce bugs. Introducing bugs means angry and a customer who may abandon your product, or you may have you will be obliged to reduce the price because your service is not it doesn't meet the quality wanted by the customer. So the first motivation of the article that was written for the Hexagonal architecture was the system can neatly be tested. I tried to resume from the article what was the motivation back in the day. The system cannot be tested. It means that the system is very difficult. Like when you want to test back in 2005, 2000, you have this like on GSP, which is Java in your HTML page, or you need to start your web server or application server, and it's heavy, it makes times, you need computing, so you end up giving up on testing. Also, the second one was the impossible to shift the use case. As I said, you want web, and you have the web to display the data or your application on the web browser. But if you would like to change and to add other technology or other output, mobile or another output, it's not easy to shift and to add it easily this new use case. Also, it was difficult to change the technology, difficult to change the framework that you are using for the for your application. If you want to upgrade or even changing, it wasn't easy, because all things was mixed. I have added some other motivations by my own. So test suite can slow down very quickly, can slow down the overall integration or deployment, because you might have some heavy testing that and heavy framework that if you want to test your application, because it is mixed, so you end up adding these tools, this framework, or this server to your test stack, and it may slow down. I witnessed some project which has 1 hour of testing or 2 hours of testing, which is a lot. The developer give up on testing. This is the for him, this, because it was like wasting his time, and he may also give up on testing at all. Changing one business logic becomes a new project. Like when you want to add the new features or new feature or fixing a bug, it may take 2 weeks or 3 weeks, because it's not easy to find where is the logic. It's not easy to find if you can reuse some logics of your business. yeah, you may end up by having this dilemma of nightmare, by having long time for one feature, and the business or the product owner might end up questioning the developer, why are you taking so much time for just this area or this input or this page? But yeah, because he cannot understand what's going on and what's left behind in the legacy code base. And developer may quit if productivity decrease, because yeah, it may be depressed and depression to work on some stressful project, especially with some tight deadline. So the overall architecture, this is here is more detailed, because the first version of the hexagonal architecture, many software engineer developed new or added new, let me say, sugar to this architecture, and you may find different way of implementing with the small change, but the principle is the same. Here is the an example of the architecture. We have this. The port is the interface, and we have the adapter, and the adapter will implement the port because we need to input and output. We need an input as an application. I need to read from the database and write to a web or an external system, and vice versa. I need to read from the web application or the mobile application, and I will end up writing on the database or some broker, messaging broker. But inside the middle, the core application is a business, and all of the stuff here can independently be changed without impacting the inside, which is not the case if we are working on a layered application. That's why it is very, very, for me, it's very practical and efficient. You will not be in a position to strictly and to have the strict boundaries between the two sides. But like when I talked about Spring, you may lessen or you may decrease your standard by adding some annotations from frameworks in the inside the business logic, because it is a trade-off. Because sometimes it may take many hours to implement properly the architecture, many classes, many interface, but progressively, it's not recommended to be really strict from the beginning, but incrementally you may ease these dependencies from the outside world, and vice versa. The outside world will not be dependent on the inside anymore. So this is an example of registration of a book. So we have these boundaries between the in and the out. The in, we have the web model or web controller, and this is the service. This is the we have this use case and the port, and we have the adapter. The port is an interface, and this is this layer of like we can say database will implement the port, and by using injection of dependencies, register book service won't know about which adapter are we using, which technology are we using. Are we using SQL Server, Oracle, MySQL, MongoDB, or AWS, or other provider of database like of cloud database? We don't care in the inside, because we have this the service depends only on the interface, which is inside the business domain or the business package, and we just implement in our adapter, and the same here. The controller will communicate with the use case interface, and the service should implement the use case interface. And the controller won't know with whom is communication with, whether it is a business or either directly with the database. It doesn't care. As I said, we have many interfaces on if we want to implement hexagonal architecture, we will end up with many interfaces, because in our layers or in the boundaries, we need to communicate only by interface. There is no concrete classes. So here it is the layered architecture, when we have the servers communicate with entity, repository, and repository maybe entity manager of Hibernate, GPA, or other, for .NET, I don't remember, it was entity, something like that. But the idea is the service in the architecture or in the layered architecture, we depend directly on the technology that we are using for storing the data. Here, we don't have this case because, as I said, the repository interface, which is the port, will have an adapter, which is a repository implementation, which will implement the repository interface, and the use case will only use the interface. It will not know about the implementation, and we need, in order to have this, we need to have a mechanism of dependency injection. We have this in the Spring framework. We have also the Google guys, and there are other. I think there is also a framework on .NET. I don't know the name, but the dependency injection, there are in many. You will find it in many languages or many platforms. It's very known. It's from the solid practice, dependency inversion. So if we can just resume what we have seen so far about what we need to remember is respect the legacy code, whatever it is, and however like it is implemented. We need to respect people who worked on tight deadline, difficult new technology with few documentation, no Stack Overflow, no YouTube to watch conference, and less documentation, less communities. So we need to honor and respect, and because sometimes we hear people complaining about who wrote this code or who wrote these features. That's why I emphasize to have this kind of empathy toward people working that worked on legacy code. But it doesn't mean that you need to stop there. It means also that we need to move on. We need to look for a better solution, for better design, and we need also be aware that if we don't design our system, our software, our application, it will design itself, and it will design itself very, very, very badly. That's why we deserve better quality of software, either for the customer, firstly, and for our team and for the whole company, because developers are the people who are in the front line and who need to be aware of their decision and to apply it in a professional way, like when we are talking about TDD or implementing this clean code. with the book of Clean Code by Martin, by Uncle Bob, which is very interesting to understand how to and what the value and why legacy or why clean code is very important. And also for the newer developer, for the onboarding, instead of wasting your time by explaining code to the newer, you may have this time with him anyway, but you will have less time to talk to him because your code is more readable, is more clear. That's why I will show you by the end. I will show you this the example of project with Hexagonal Architecture, which is very easy to read, and you can spot directly which features is implemented by which package, instead of having this abstract package like when we work with layered architecture, we have controller, servers, entities or repositories. We don't know which features, especially if we have this deep nested package. But with Hexagonal Architecture, as I said, Hexagonal Architecture, you will end up finding many way of how to organize package. But the code I will show you right now, it's more explicit to see the which features is implemented and where is the adapter, where is the port, and etc. So let me just check and change. I will just change it to okay. This is the code base I have talked about. Here is the repository on GitHub. I will send the slide by the end of the week on my Twitter account, so you can download the slide and you can also check all the links I put, especially at the end. Other links that it might be useful to explore more on this topic. So as I said, if I just open the project, I can see directly I am looking on package, organized package with account, and I can see that we have account features. And if I explore further, I can see domain. Where is the domain directly? And here I have this domain in these two. I have this domain in application and domain layer, because here also I have service, and this service have some rule to send money from account to account. So I need some business logic like locking. If we can see here, I don't know if we zoom a little bit, so we can see it. We can see that we are handling business logic, but it is very clear from package structure. And if we just look in what we implement is an interface, and this interface is used by a controller. Because the controller know only the interface, which is for him just to fulfill a role to send in information to either to get information or to send the information to be stored on database or other storage technology. So send money controller, and also if we can see, send money controller is using the update port, and the update port is an interface, and this interface is implemented by the repository, which will store the data. So if we can see, yeah. So here we have this storage, the storage adapter, and we have repository, and we can see that we are in this package adapter. And we have entity as well. This is the entity that is used. And we have this mapping, kind of mapping, because we need to map when we go from the domain model. We don't want to send our entity. We send activity. We have a mapper that we have the mapper that change the data, or can say transforming the data to be to fit what the repository need, because we have this kind of boundaries. But in general, I will put all my slides and with links to this project and other links to the article and other projects, so we can explore more and check how you can implement this architecture on your code base. But as I said, working especially on the code that is changed, that is changing very frequently, and without rushing and on a whole code base because you need to make a point that this architecture may help to reduce bugs, more readability, and also more and easy to change and easy to implement or to add new technology or new frameworks. There's also a test, and in this test we have this checking that we check all the features. But also I want to mention this ArcUnit, because with ArcUnit, it is a framework that is that you can use on your project, and you can add the test to check whether you respect the boundaries. Like you can say, I don't want any Java X persistence package inside my application or inside domain, which is what we want. We don't accidentally end up by a new developer adding entity manager or other frameworks, technical framework on our domain. So we can have this. You can add an ArcUnit to create a rule that will fail if we don't respect these boundaries between the inside and the outside of the hexagonal architecture. So I'm going to come back to the presentation. So I end up by losing my tab. Oh yeah, here we are. Now the boi's code rule is always clean. Leave the code you are editing a little better than you found it. By editing a little better, not the whole project, or not not to rush, but a little better and to move on. This is the agile or incremental workflow, because if not, it will be very stressful to add many or to change, which may be not easy for the developer and also for the product as well, which may introduce bugs. And yeah, so thank you for your attention. I would glad to have your questions, or even after the session, I can be around to ask any questions or to discuss any topics around this hexagonal architecture or the clean code or the legacy code. Thank you, and have a very pleasant ending of conference. I will let Scott take back, or slide will be available on my Twitter at Oussama BADR. Thank you very much, and have a nice day.